Good day, everyone. Today we're gonna talk about amines. So, amines are organic compounds containing nitrogen atoms with a lone pair of electrons. They can be viewed as derivatives of ammonia. Derivatives means it is a substance that is created via chemical reaction from another component, where one or more hydrogen atoms have been replaced by alkyl or aryl groups. So, here are the basic structure of amines. Follow this pattern. Primary amines. Primary amines consist of one alkyl or aryl group attached to nitrogen. Secondary amines when two alkyl or aryl groups attached to nitrogen. Third amines when three alkyl or aryl groups attached to nitrogen. And lastly, quaternary ammonium compounds when four alkyl or aryl groups attach to nitrogen, forming a positively charged ion. The nitrogen atom in amines contains a lone pair of electrons, making amines act as bases. This lone pair can accept a proton from acids, forming ammonium ions. The basic strength of amines depend on the availability of this lone pair of combination. Here are some examples of common amines, including methylamine. Methylamine is found in a rotting fish. Next is dopamine, or what we call a feel-good hormone. It is a neurotransmitter in the brain. Next is amphetamine. Amphetamine, a stimulant used in some medication. Lastly is aniline. Aniline is used in dye production.
What are amines? Amines are organic compounds containing nitrogen atoms with a lone pair of electrons. They can be viewed as derivatives of ammonia or NH3, where one or more hydrogen atoms have been replaced by alkyl or aryl groups. The basic structure of amines follows this pattern. Primary amines are 2NH2, one alkyl or aryl group attached to nitrogen. Secondary amines are 2NH, two alkyl or aryl groups attached to nitrogen. Third amines are 3,2N, three alkyl or aryl groups attached to nitrogen. Quaternary ammonium compounds are 4N, four alkyl or aryl groups attached to nitrogen, forming a positively charged ion. The nitrogen atoms in amines contain a lone pair of electrons, making amines act as bases. This lone pair can accept a proton from acids, forming ammonium ions. The basic strength of the amines depends on the availability of this lone pair for donation. Examples of common amines include methylamine, CH3NH2 found in a rotting fish, dopamine, a neurotransmitter in the brain, amphetamine, a stimulant used in some medications, aniline, C6H5NH2 used in dye production.
The nomenclature of amines follows specific rules depending on whether we use common names or IUPAC systematic naming. Common naming system. For simple amines, the alkyl group name is followed by the word amine. Examples: CH3NH2 methylamine, and another is CH3CN2NH4 ethylamine, and CH3 2NH dimethylamine, and CH3 3N trimethylamine. For mixed amines, different alkyl groups we list all groups alphabetically: CH3NH, CH2, CH3 ethylmethylamine. IUPAC naming system. The IUPAC system uses prefixes to indicate the amine type. Primary amines use amino as a prefix to the parent chain. Secondary and tertiary amines use N with substituent names. For simple cases, find the longest carbon chain and number the chain to give the amino group the lowest possible number. Add amine as a suffix to the parent chain name. Examples using IUPAC system: CH3, CH2, CH2, and H2. Propan 1-amine or 1-propanamine. C6H5 and H2 benzenamine or aniline by common name. CH3, CH2, NHCH3, and methylethanamine. For cyclic amines with a nitrogen as part of the ring, aziridine, 3-membered ring with 1 nitrogen, ferrolidide, 5-membered ring with 1 nitrogen, piperidide, 6-membered ring with 1 nitrogen. That's all for naming amines.
Reactions of amines. Amines participate in numerous reactions due to the nucleophilic nitrogen atom with a lone pair of electrons. First reaction is basicity reactions. Amines react with acids to form ammonium salts. So this is the formula. Example for basicity reactions is when methylamine reacts with hydrochloric acid, and it will form like this, and the result would be methylammonium chloride.
Hello everyone. So now we will go to the alkylation reaction. In this reaction, amines can be alkalized to form secondary, tertiary amines or quaternary ammonium salts. For example, methylamine can react with chloroethane. So in this example, methylamine is acting as a nucleophile. Its nitrogen attacks the carbon attached to chlorine and chloroethane. The carbon-chlorine bond breaks, and the chlorine leaves with the electron pair. The nitrogen forms a new bond with the ethyl group, creating N-ethylmethylamine, and the displaced hydrogen combines with chloride to form hydrochloric acid.
For the third example is acylation reaction. When amines react with acid chlorides or anhydrides to form amines. For example, when aniline reacts with acetyl chloride. Aniline plus acetyl chloride, the product is acetanilide. Thus,
Fourth reaction of amine is Hofmann elimination. Quaternary ammonium hydroxides undergo elimination when heated, and the formula for that is this.
So now, let's proceed to the reactions with nitrous acid. Primary aliphatic amines react with nitrous acid to produce nitrogen gas. For example is when aniline reacts with nitrous acid. Aniline is an aromatic primary amine. When treated with nitrous acid, it forms benzene-diazonium chloride.
for the number 6, we call it Gabriel synthesis. It is a method to prepare primary amines using phthalimide. Here are the example. First is the phthalimide plus potassium hydroxide, forming potassium phthalimide. Second is potassium phthalimide plus RX, forming its N-alkyl phthalimide. Third is N-alkyl phthalimide plus hydrazine, forming its primary amine plus hydrazide.
Now, let's proceed to reduction reactions. In this reaction, nitro compounds can be reduced to form amines. For example, nitrobenzene can be reduced to aniline. To do this, we will start with the nitrobenzene, and then we will add hydrogen, which acts like a chemical magnet that is strongly attracted to oxygen. The hydrogens pull away the oxygens from the nitrogen atom, forming two water molecules. At the same time, some of the hydrogens attach to the nitrogen, creating an amino group, which will give us aniline. And finally, we have the coupling reactions. In this reaction, diazonium salts couple with aromatic compounds to form azo compounds. For example, is the benzene-diazonium chloride couples with phenol. To do this, we'll start with the benzene-diazonium chloride and phenol. The diazonium ion attaches to the phenol molecule at this electron-rich spot. This forms a new bond between the two molecules, creating an azo linkage. A hydrogen atom gets kicked off from the phenol during this process, which will give us the final product, which is the 4-phenyl-azophenol.
In summary, amines are nitrogen-containing organic compounds derived from ammonia. They feature a nitrogen atom with a lone pair of electrons, making them basic and nucleophilic. The classification of amines includes primary amines, secondary amines, tertiary amines, quaternary ammonium compounds. Naming conventions follow either common names alkyl plus amine or IUPAC systematic rules using prefixes and position numbers. The chemistry of amines revolves around several K reactions: basicity reactions forming ammonium salts, alkylation to form higher order amines, alkylation producing amides, Hofmann elimination, reactions with nitrous acid, Gabriel synthesis for preparing primary amines, reduction of nitro compounds, and coupling reactions of diazonium salts. Amines served as precursors for many products, including pharmaceuticals, polymers, dyes, and agrochemicals. Their ability to form hydrogen bonds makes them water-soluble at lower molecular weights, while their basic properties allow them to neutralize acids. Understanding amine chemistry proves essential for students of organic chemistry and professionals working in chemical synthesis, drug development, and materials science.